Hi, I'm Pat Koszczaba, and you are watching a NetTouch series about agile design patterns. This lesson will be about the command pattern. As you can see in this schema, it is a very simple and very effective pattern. All it does is define an interface of type command, which has a single method called execute. This type of solutions are very useful when you have something like a sensor waiting for an event to happen. When that does happen, it executes the command. It doesn't know how the command looks like or what it is good for. It just executes it. So, a command can be implemented in many ways and provide many functionality without its client knowing its inner workings. For example, such a command pattern can be used when we process payments for our online webshop application. A process payment class will ask a user class to provide a payment method. This payment method will be in fact a command. The process payment will execute the command without knowing the type of it. Let's create the pieces required to implement this schema. We'll start with a user class. As I mentioned, it will have a private variable defining a payment method. The method will be provided by a function called getPaymentMethod. This function will return our private variable. Please note that this variable can be of two types, or an object being an instance of a Visa payment class, or another object being an instance of a PayPal payment class. Let's see how these classes are implemented. The first step is to ensure we have an interface with an execute method. This would be a payment method interface, having a function called execute. Then, PayPal payment will implement a payment method. To do so, it has to provide the defined execute method. On the other hand, we can have a Visa payment also defined in a similar way. We will specify that it implements payment method and the required implementation. For our example, this is enough. In a real world, here would be a lot of logic about how to pay for a product with Visa. We have our command interface, in our case the payment method. We also have a user class capable of providing implementations of this interface. The next logical step is to implement the client of our command. In our case, this will be the process payment class. It will provide a function called processUserPayment. It will have a parameter as a username, and it will be responsible of paying for the product as defined by the methods in the user class. We'll create a local user variable, which will be a new user object created from the name got as parameter. The next step is to obtain the payment method we will use. So we will have a local payment method variable obtained by calling user getPaymentMethod. Next, we will call execute on the payment method using a private method called executePayment, and having the parameter our payment method. This function will try to execute the payment, and if it fails, it will throw a new exception. What is interesting here is the fact that the executePayment function does not actually know what type of payment it has to do. All it knows is that the payment method specified should have an execute method. In order to do this concatenation here, probably the payment method should implement a toString version to provide its type. Something like this. If we do this, using the class in a concatenation in a string, like in process payment, will create a nice message saying that paying with PayPal failed with the following error, and we can take the error message provided by payment error execute. One last step is to define the payment processing exception. In our case, it is nothing more than an extension of the built-in exception class and calling its constructor with the message provided by our caller. The power of the command pattern is that it opens doors to some interesting solutions, like transaction. Imagine you are a bank and you are about to implement a solution for payments. All payments go as a transaction. It will have a start point, some values set up and then executed. Also, the user may undo its last transaction. These kind of solutions are used when you are using the undo function in many user interfaces. What is happening there is that the command objects, after executing themselves, are put on a list. Whenever you call the undo in your user interface, the most recent element in the list is taken and an undo method is called on it. If it implements correctly the command, it will know how to undo whatever it executed. That was all for this lesson. See you next time with an extension of the command pattern called the active object.